Hello everyone, welcome to DEEPTHI Academy. In this one video, I will bring to you some of the important MCQ on the lesson light, reflection and refraction. So already the part 1 of this one topic already I have uploaded the video, and here some other important questions according to the new pattern by the Cbse board for the term 1 examination for the academic year 2021-22. So based on that one, I have collected few of the important questions. So let's start the video. Here is the first question. The refractive index of glass for light going from air to glass is 3/2. The refractive index for light going from glass to air will be. So here they have given the refractive index. So the refractive index of glass to air is 3/2. Okay, now they are asking the refractive index of air to glass is equal to how much, right? And here we have the formula that refractive index of glass to air is equal to 1 divided by refractive index of air to glass, right? So this is equal to, you can write here refractive index of air to glass 1 divided by, that is the refractive index of glass to air is how much? It is 3/2, right? Now this can be written as, you take to the numerator, it is 2 divided by 3. So here we got the answer 2 divided by 3, but in the lesson here we have 4 divided by 6, right students? In the lesson we have 4 divided by 6, 1/3, 4/5, 5/2. So here we will get confused. So there is no option 2/3 in the question. So look at here carefully, the option C. If you divide this one 4/6, you will get 2/3. So here option C is the correct answer. Next question. The refractive indices of 4 media A, B, C and D are 1.44, 1.52, 1.65, 1.36 respectively. When light traveling in air is incident in these media at equal angles, the angle of refraction will be minimum in which medium? So in order to solve this one question, here we need to understand the relationship between the speed of light and the refractive index. We know that refractive index is equal to C divided by V. So here the relation between the refractive index and the velocity of light, they are inversely proportional to each other. So whenever the speed of light decreased, the refractive index is increased. Okay, now just keep this one idea in your mind. So let us draw one diagram. So let us suppose that this is the ray of light, this is normal. Okay, now the refracted ray is bending towards the normal. So here the angle of incidence and this is the angle of refraction, right? Here we want that in which medium, so in which medium the angle of refraction is minimum. So this angle of refraction is minimum in which medium? Now you can see here, these are the four values they have given. These are all refractive index. So here we know the relation, whenever the refractive index is high, the speed of light decreased. Okay, so here 1.65 is the highest refractive index among all the media. Okay, so highest means the speed of light is minimum. So speed of light is minimum means here the refractor, the ray, that is the refractor ray is bending towards the normal, or you can understand the air is the light is traveling from rarer to denser. The bending is here, the bending of light is going to take place decreased. So the speed of light is decreased. So here the refraction is minimum means the speed of light is decreased. So when the speed of light is decreased, here the refractive index is maximum. So here option C is the correct answer. Next question. The speed of light in substance X is 1.25 into 10 raised to 8 meter per second, and then in air 3 into 10 raised to 8 meter per second. The refractive index of this substance will be. So here is the question. So here we have to calculate the refractive index of this substance. So in order to calculate this one, we have the formula, the absolute refractive index formula. N is equal to C divided by V. So the speed of light in air, it is 3 into 10 raised to 8 meter per second, divided by the speed of light in the substance. We have 1.25 into 10 raised to 8 meter per second. So 10 raised to 8, 10 raised to 8, both are get cancels together. So you simplify this one, you are going to get, so here in the numerator you will get 300 divided by 125. So simplify this one, you will get 2.4. So the refractive index of the substance is 2.4. Option A is the correct answer. Next question. The refractive indices of four substances P, Q, R and S are 1.77, 1.50, 2.42 and 1.31 respectively. When light traveling in air is incident on these substances at equal angles. Okay, so at equal angles the light is going to be incident. The angle of refraction will be maximum. So when is the angle of refraction is maximum? So in order to solve this one question, we know that the relation between velocity of light and the refractive index. The velocity of light and the velocity of light in a substance and the refractive index both are inversely proportional to each other. So here the speed of light is decreased, means the refractive index is maximum. The refractive index is maximum in that one substance when the speed of light is minimum. So here we want the answer. So let us understand with the diagram. So this is the incident ray. This is the actual path of ray of light, and the refraction, the angle of refraction is maximum. So it means it is bending away from the normal. It is bending away from the normal. So bending away from the normal. So when the light is coming from one medium to the another medium. So the speed of light increased. So bending away from the medium means, so this, in this one case, the speed of light is increased. Because of that one, the refracted ray is bending away from the normal. So when the speed of light is increased, obviously the refractive index should decrease, right? So among four substances, which substance is having the least refractive index? So the least refractive index, you're having 1.31 is the least refractive index. So here the answer is, that is 1.31 is the substance is S, and here the option D, substance S, is the correct answer. Next question, the refractive index of water is, so here the refractive index of water, direct question, the refractive index of water is 1.33. Next question, the refractive index of water with respect to air is 4/3. The refractive index of air with respect to water will be, okay, so here we have refractive index of water with respect to air is equal to, we have 4/3, okay, and we have to calculate refractive index of air with respect to water is equal to question mark. We have to calculate this one, and here we know the formula. Refractive index of water with respect to air is equal to 1 divided by refractive index of air with respect to water, right? Here we know refractive index of water with respect to air is, it is how much? It is 4/3. This is equal to 1 divided by refractive index of air with water. This is equal to, it can be written as refractive index of air with respect to water is equal to, you can write this one directly, so take to the RHS side, so it is 1 divided by 4/3, take to the numerator, it is 3/4. So simplify this one, you will get 0.75. So the option C, 0.75 is the correct answer. Next question, a converging lens is used to produce image of an object on the screen, right? And what change is needed for the image to be formed nearest to the lens? In order to form a nearest to the lens, the image nearest to the lens, so what should be done? So first is option A, increase the focal length of the lens. So here if you increase the focal length of the lens, as we know for the converging lens, that is the convex lens. So if you have kept the object in between the focus and the optic center, the image is virtual and erect, okay. So let us show you the diagram. This is the converging mirror, the convex mirror, this is optic center, this is focus 1, this is focus 2, this is center of curvature 1, this is center of curvature 2, okay. Now in order to get the image of an object on the screen, the changes should be done. So the image form should be nearer to the lens, so they have given option A, increase the focal length. So if I increase the length of this one focal length, the image cannot be formed near to the lens, so option A is not correct, right? And the second option we have, insert a diverging lens between the lens and the focus. So this is also not the good idea in order to get the image near to the lens. So next we have, increase the distance of the object from the lens. Yes, So if you increase the distance of the object from the lens, so you can get the image nearer to the lens, because if we have kept the object at infinity, the image is formed at focus, right? If we are kept beyond C1, the image is going to form between C and F, right? So here, in order to form the image near to the lens, you have to increase the distance of the object from the lens. So here option C is the correct answer. Next question. A convex lens has a focal length of 10 centimeter. At which of the following position should an object be placed so that this convex lens may act as a magnifying glass? So in order to act as a magnifying glass, the convex lens, where should be the object should be kept, and which is having the focal length 10 centimeter, right? So this is the convex lens, optic center, focus, and the center of curvature first. This is the focus first, second, and center of curvature is here, right? And here the distance between the optic center to the focus, that is the focal length, it is 10 centimeter, right? So here this lens should act as a magnifying glass, which means the object should be kept in between the focus and the optic center, right, in order to act as a magnifying glass. And here the convex lens is going to produce the virtual and erect image when the object kept between optic center and the focus. So here you can see here the distance which is less than 10 centimeter. Now you just check it in the option that, so 7 centimeter, which is less than the focal length, right? So the answer is 7 centimeter. Next question. A small bulb is placed at the focal point of a converging lens. When the bulb is switched on, the lens produces. So the option A, we have convergent beam of light. Option B, we have a divergent beam of light. Option C, we have a parallel beam of light. And option D, we have a patch of colored light. Here, as the lens is the converging lens, when the light is switched on, the bulb is switched on, the lens produces the parallel beam of light. The lens produces the parallel beam of light. So answer is option C. Next question. An illuminated object is placed at a distance of 20 centimeter from a converging lens of focal length 15 centimeter. The image obtained on the screen is, okay, so here we have a convex lens, and the object has kept at 20 centimeter. So let us suppose that this is the focus first and this is center of curvature first, and the focal length is 15 centimeter. Okay, now the object has kept at the distance 20 centimeter. Let's suppose that the object is here. It means the object is kept between center of curvature and the focus. And we know that when the object has kept between center of curvature and the focus, the image is going to form behind the center of curvature, that is C1, and it is enlarged image. It is real, inverted, and enlarged. So just check out in the option, upside and magnified, no. Inverted and magnified, okay, it is inverted and magnified. Inverted and diminished, no. Upright and diminished, no. So here the option B is the correct answer, that is inverted and magnified. So next question. An object is placed between f and 2f of a convex lens. Which of the following statement correctly describe its image? So as in previous question I have explained, that is the object is between f and the 2f, the image is going to form behind the center of curvature 1 and it is real and inverted, okay, and it is enlarged. So just check out in the option that which is having the option A, that is it is real larger than the object. So option A is the correct answer. Next question, which of the following can make a parallel beam of light, or when light from a bulb is on? So which will produce the parallel beam of light? So option we have concave mirror as well as concave lens. No, concave lens will not produce the parallel beam. Convex mirror, no, convex mirror will not produce the parallel beam. Option C we have concave mirror as well as convex lens. Yes, these concave mirror and the convex lens, these two will produce the parallel beam of light. So let's check out the option D also. We have convex, no, convex will not produce the parallel beam of light. So here the option C is the correct answer. Next question, in order to obtain a real image twice the size of the object with a convex lens, right, of focal length 15 centimeter, the object distance should be, okay, so we have a convex lens, right, which is having the focal length 15 centimeter. So f is 15 centimeter, and in order to get the real image twice the size of the object, where should be the object has to be kept? Okay, so twice the, it means the image should be larger than the object, right? So here we have the option A, more than 5 centimeter but less than 10 centimeter. So if you have kept the object more than 5 centimeter but less than 10 centimeter, you will not get the enlarged image. So let's move to the option B, more than 10 centimeter but less than 15 centimeter. No, this will not give them twice the size of the object. So you can see here option C, more than 15 centimeter but less than 30 centimeter. Yes, so here if you have kept the object between the center of curvature and the focus, you will get the image, a larger image. So here the option C is the correct answer. Next question, a linear magnification produced by a convex lens can be. So as we know, that is the magnification. So here convex lens, it is going to produce diminished image, highly diminished image, same size image, and enlarged image. Okay, so it means the magnification is it is like equal to 1 or more than 1 or less than 1. So here we have the option D, that is less than 1, equal to 1, or more than 1 is the correct answer, because convex lens, it is the lens that is going to produce the image diminished, highly diminished, same size, and also that is enlarged. So all the size images it will form. So the option D is the correct answer. Next question, magnification produced by a concave lens. So here we have in this one question concave lens. So concave lens, it will produce the image like that is the virtual and erect image and behind the lens, right, and it is always like a diminished image. So in order to define in terms of magnification, here the magnification, it is always less than 1. Why? Because it is going to produce the image, diminished image. Diminished means it is less than 1. Are you getting? Diminished means less than 1, same means equal to 1, enlarged means more than 1. So here concave, it will produce a diminished image, which means magnification is less than 1. So option C is the correct answer. Next question. In order to obtain a magnification of -3 with a convex lens, the object should be placed. So in order to get the magnification -3, where should be the object has to be kept? So option A we have between the optical center and the F. No, here if you have kept the object in between optical center and the F, you will get the virtual and erect image. So virtual and erect image magnification is plus. So option A is not correct. And option B we have between F and 2F. Yes, so here if you have kept the object between F and 2F, you will get the magnification like the image is going to be form a real and inverted and it is enlarged. So here option B is the correct answer. You can check the option C also at 2F. So at 2F, if you have kept the object, you will get the same size of image as the object. So option C is not correct. And beyond C, okay, so beyond C1, like the image is enlarged and magnification is not the as high. So here option B is the correct answer. Next question. A convex lens produces magnification of +5. The object is placed. So here we know that the magnification for the convex it is plus. So here plus means when will be the convex lens produces the virtual and erect image? When the object has kept in between optic center and the focus, right? So here in order to get the +5 magnification, the object should be kept less than F. So here option C is the correct answer. If a magnification of -1 is obtained by using a converging lens, that is convex lens, then the object has to be placed. Where should be the object has to be placed in order to get the magnification -1? So -1 means that is the image is of same size of the object. So when the convex lens is produces the same size of the image, when the object has kept the at 2F, okay, at 2F. So here the option B at 2F is the correct answer. Next question. To obtain a magnification of -0.5 with a convex lens, the object should be placed. So here -0.5 means it is diminished image. Okay, so when the convex lens will produces the diminished image, when first one is the object has kept at infinity, and second one is the object has kept beyond center of curvature, that is 2F here. So here we have option D, that is beyond 2F. In order to get the magnification -0.5, object has to be kept beyond 2F. Next question. An object is 0.09 meter from a magnifying lens and the image is formed 36 centimeter from the lens. The magnification produced is, so it is a numerical question, and here we have that is they have given the object distance is 0.09 meter. It is meter, okay, and they have given that is the image is going to form at 36 centimeter. So they have given 36 centimeter, right? So what is the magnification? So we know that the magnification formula, that is V divided by U, right? Now we have we have 36 and U we have 0.09 meter. Now convert into 0.09 meter into centimeter, right? Because we have in centimeter. So if you convert, you will get 9. So simplify this one. So you will get 4. So magnification is 4. So here in the option we have option C 4.0. So the correct answer is option C 4.0 is the correct answer. Next question. A convex lens of focal length 15 centimeter produces a magnification of +4. Right. The object is placed. Look at here. The convex lens is having the magnification +4. So +4 means the convex lens is going to be produces the image which is virtual and erect. Right. Magnification is plus means the image is virtual and erect. Right. So when the convex lens will produces the virtual and erect image, the object has kept between optic center and the focus. So here the focal length they have mentioned 15 centimeter. So it should be like it is less than 15 centimeter. If you have kept the object, you will get the magnification +4. So here option C less than 15 centimeter is the correct answer. Next question. If a magnification of -1 is to be obtained by using a converging lens, that is the convex lens of focal length 12 centimeter, the object must be placed. So you just see a magnification we have -1, which means that is the image is of same size. So when the image is produced by the convex lens is same size, when we have kept the object at center of curvature, right? When we have kept the object is at center of curvature. And here they have given the focal length is 12 centimeter. So center of curvature, it is equal to 24 centimeters. So option B is the correct answer. Next question. In order to obtain a magnification of -0.75 with a convex lens of focal length 8 centimeter, the object should be placed. So where should be the object? So magnification is -0.75 means it is the image is diminished image, right? Less than 1 means it is diminished. So when the convex lens will produces the diminished image only at two conditions. One is the object is infinity, and the second one is the object beyond center of curvature. So here they have mentioned the focal length is 8 centimeter. So 8 centimeter means like you double it, the center of curvature is 16 centimeter. So if you have kept the object beyond center of curvature, you will get the magnification is 0.75. So option C beyond 16 centimeter is the correct answer. A diverging lens is used in, so diverging lens, that is concave lens. So concave lens it is used in spectacles for the correction of short sight. So option C is the correct answer. Next question. When an object is kept at any distance in front of a concave lens, so the image is, so concave lens, it will always produces virtual, erect and diminished image, as we know from the ray diagram, right? So here option C is the correct answer. Next question. When sunlight is concentrated on a piece of paper, okay, by a spherical mirror or a lens, right, then a hole can be burnt in it. For doing this, the paper must be placed at the focus of what? So in order to burn the paper, so the at the focus, right? So at the focus, the object, like we have to be concentrate the sunlight either the concave mirror or convex lens, because these two are the converging mirror and the converging lens. So option C is the correct answer. Next question. A beam of parallel light rays is incident through the holes on one side of a box and emerges out the holes in its opposite side as shown in the diagram, right? So which of the following could be inside the box? So here, as we know, the beam of light is going to be incident, so it is just emerging out and it is converging at the point. So here the answer is, we have the inside the box, that is the rectangular glass block. So option A is the correct. Sorry, it is not a rectangular glass block. It is as the refracted rays are converging at a point, which means it is a convex lens. So here option C is the correct answer. Next question. A beam of light is incident through the holes on one side of a box and emerges out through the holes in its opposite side as shown in the figure, right? So you can see here the beam of light is incident and the refracted rays are diverges. So as the refracted rays are diverges, which means we have inside the box we have a concave lens, because concave lens is a diverging lens. So option B is the correct answer. Next question. Which of the following can form a virtual image or which is always smaller than the object? So virtual image which is always smaller than the object, it is obviously concave lens. Next question. The magnification produced by a spherical mirror and a spherical lens is plus 0.8. So the options we have, that option A, the mirror and the lens are both are convex. Option B, we have the mirror and the lens are both are concave. Option C, we have the lens and we have the mirror is concave but the lens is convex. Option D, we have the mirror is convex but the lens is concave. Just you understand here, the magnification they have given plus 0.8. So plus 0.8 means that is here the image is diminished, right? Image is diminished. So from the following, which the lens is, that is the mirror, you see here option D, the mirror convex, it will produce the magnification smaller, that is the magnification is like smaller, the image is smaller than the object. And also the lens, concave lens, it is also produces the, that is the diminished image. So here option D is the correct answer. Next question, we have the magnification produced by a spherical lens. We have spherical lens and a spherical mirror is plus 2.0. So here also the same case, just as I explained in the previous question, that the lens having the magnification plus 2. So plus 2 means that is the option C, that is we have the lens is convex but the mirror is concave. The next question, the power of a concave lens is 10 diopter and that of a convex lens is 6 diopter. When these two lenses are placed in contact with each other, the power of their combination is. So here, so whenever the two lenses we are going to be contact with one another, the total power of the lens, it should be like the algebraic sum of the power of the lenses, that is the total power. So the lens, just I will take P1 and for the lens second one I will take P2. So what is the power of the first lens? It is 10 and second is 6. So add these two, you will get 16. So 16 diopter is the total power of the lens. So here we have option A plus 16 diopter is the correct answer. Next question, the power of a converging lens is 4.5 diopter, and that of a diverging lens is 3 diopter. The power of this combination of lenses a bit close together is, so here also we have to follow the same method to solve this one, but here look at here, the converging lens, we have the power, that is P1, we have the power, it is plus 4.5 diopter because it is the converging. So, and as the second lens it is diverging lens, so here the power it is in negative, so I have to take here minus 3 diopter because as it is the converging lens. So just now we want the total combination of power of these two lenses. So total power P is equal to P1 plus P2 you do, so 4.5 minus 3, so this is equal to, you will get plus 1.5 diopter. So option A, 1.5 diopter is the correct answer. Next question, we have the focal length of 4 convex lenses PQRS are 20 centimeter, 15 centimeter, 5 centimeter and 10 centimeter. The lens is having the greatest power. So which lens is having the greatest power? We know the relation that P is equal to 1 by F. That is, power and the focal length are inversely proportional to each other. So here, as the focal length is decreased, the power is increases, right? So just check the focal length which is having the least focal length. So here 5 centimeter is having the least focal length, that is R. The lens R is having the least focal length, which means it is having the greatest power. So option C, R, that is the lens R is the having greatest power. Next question, a converging lens has focal length 50 centimeter. The power of the lens is, so as we know the formula, P is equal to 1 by F. So power, we have to calculate the power, so 1 divided by F. F is 50 centimeter. Now convert into meter, so here you will get 0.5, 1 by 0.5. Now you simplify this one, you will get 2 diopter. So plus 2 diopter is the answer. So here option C is the correct answer. A diverging lens has a focal length of 0.10 meter. The power of the lens will be, so here as we know power P is equal to 1 by F. So P we have to calculate, so F we have 0.10 meter, it is 0.10 meter. Here we have to note that the focal, as it is the diverging lens, the focal length is negative as it is the diverging lens, so we have to take the minus sign. So simplify this one, you will get minus 10 diopter. So option D, minus 10 diopter is the correct answer. Next question, the power of a lens is plus 2.0 diopter. Its focal length should be, okay, so we have the formula P is equal to 1 by F. They have given the power is plus 2 diopter, okay, so I will write 2 is equal to 1 by F. So you can write F is equal to 1 by 2. So 1 by 2 means it is 0.5. it is meter, focal length it is in meter, but we need to calculate in centimeter. So in centimeter you will get 50 centimeter. So here we have the answer, that is option B, 50 centimeter is the correct answer. Next question. If a spherical lens has a power of minus 0.25 diopter, the focal length of this lens will be, okay, we have the formula, power is equal to 1 by f, right? And they have given the focal length is 0.25. So here I can write f is equal to 1 divided by 0.25. So simplify this one, you will get so in the numerator I can write 100 divided by 25, and here as the focal length they have given, it is in minus. So just simplify this one. So 25 ones are 25, 25 4 are, it means minus 4. The focal length is minus 4. So here option C, minus 4 meter is the correct answer. Next question. Which one of the following materials cannot be used to make a lens? So here the option D, clay cannot be used to make the lens. Next question. The image formed by a concave mirror is observed to be virtual, erect and larger than the object. Where should be the position of the object? So here the concave mirror, it will produces the virtual, erect and larger only at the one condition, when the object has kept between the pole and its focus. So option D is the correct answer. Next question. Where should an object be placed in front of a convex lens to get a real image of the size of the object? So here, in order to get the real image for a convex lens, so the object should be kept twice the focal length, that is at the center of curvature. So option B is the correct answer. Next question. A spherical mirror and a thin spherical lens have each of a focal length minus 15 centimeter. The mirror and the focal and the lens are likely to be. So option A we have both concave, option B we have both convex, option C we have the mirror is concave and lens is convex, option D mirror is convex but the lens is concave. So just to see the question here, we have the focal length minus 15 centimeter. So focal length for the concave mirror, it is in minus, right? And for concave also the focal length is minus here, which means both the mirror and the lens are concave. So option A is the correct answer. Next question. No matter how far you stand from a mirror, your image appears erect, right? The mirror is likely to be option A plane mirror, option B concave. Concave this will not possible, always the erect image. Convex, okay, it's possible, but in option D we have both the plane mirror and the convex. So here option D, the plane mirror and the convex will always produce like the erect image. So option D is the correct answer. Next question. Which of the following lenses would you prefer to use while reading small letters found in the dictionary? So which lens will you prefer? So option A we have the convex lens of focal length 50 centimeter. And option B have concave lens. Concave is the diverging lens, so we can't use for the reading. convex lens of focal length 5 meter, concave, so it is not possible, delete the option D also. So here we have option A and option C. So as the focal length is less, so the more converging power, so which means which can be used for the reading purpose, which is having the focal length 5 centimeters. So option C is the correct answer. Next question. The angle of reflection is the angle between. So the angle of refraction, it is the angle between the normal to the surface and the reflected ray. A virtual image is always formed dash with respect to the object. So the virtual image, it is always formed with respect to the object is on the top of opposite side of the plane mirror. So option B is the correct answer. Next question. The point on the principal axis where the rays are parallel to the principal axis converge or appear to diverge after reflection, it is called as focus. So option D is the correct answer. The focal length of a spherical mirror whose radius of curvature is 20 centimeter. So what is the focal length? We know that the relation R is equal to 2f. We have radius of curvature is 20 centimeter. Therefore f is equal to 20 divided by 2. This is equal to 10 centimeter. So option D is the correct answer. Next question. If an object is placed 15 centimeter in front of a concave mirror, so mirror is concave, a focal length is 30 centimeter, then the image, so here as the focal length is 15 centimeter and the object is placed at 15 centimeter, which means that here the image is enlarged and upright and virtual. So the option B is the correct answer. Next question. A ball is held 50 centimeter in front of a plane mirror. The distance between the ball and its image is. So here we have one plane mirror and here we have one ball which is at 50 centimeter from the plane mirror, and the image of this one ball is going to form like behind the mirror, which is at the same distance, that is 50 centimeter. And the question is the distance between the ball and its image. So the distance between the ball and its image, it is 100. 50 plus 50, it is 100. So option A is the correct answer. Next question. At what distance in front of a concave mirror must an object be placed so that the image and the object of the same size? So image and the object of the same size, so the object should be kept that is twice the focal length. Object should be kept twice the focal length is the correct answer. For an incident ray directed towards the center of curvature of a spherical mirror, the reflected ray. So whenever the ray of light is traveling through the center of curvature of a spherical mirror, it will retrace the same path. So option A is the correct answer. Next question. A mirror which can produce a magnification of +1 is. So the +1 magnification of the mirror is plane mirror. So plane mirror magnification is +1. The mirror used by a dentist to examine the teeth of a person is, it is concave mirror. So these are some of the important MCQs on the lesson light, reflection and refraction. Do subscribe to my channel. Thanks for watching.